Hello and welcome to Equivalent Ratios. Today we are going to be finding equivalent ratios, and then I'm going to give you two ratios and you get to determine if they are equivalent or proportionate is the word we'll use today as well. So, let's talk about what are equivalent ratios, aka also known as proportions. You're going to hear me say equivalent ratios, you're going to hear me say proportions, and they're the same thing. They are two ratios that express the same relationship. You can kind of think of these as equivalent fractions, right? 1/2 is equivalent to 5/10. Those are equivalent fractions. If we're talking about ratios, like for every one head, there's 2 ears. Well, that's the same for every 5 heads, there's 10 ears, right? They are also equivalent ratios, or they're proportionate with each other. So that's the vocab for the day. We will hear them often today. We have two things that are going on today. First thing we're going to do is we're going to create equivalent ratios. And then, like I said, I'll give you two ratios and you get to decide if they're equivalent, if they're proportionate. Why, you ask, why do we need to learn this? There are lots of instances in real life where you need to keep things proportionate, where you need to keep things equivalent. For example, when Crumbl was creating their business, they only made small batches of their cookies until they got like the perfect recipe, right? So if they were making their cookie, they might try 2 cups of sugar and 3 cups of flour, and they might figure out that it is the perfect ratio of sugar to flour, correct? So they've got the perfect thing. Well, what do they do now if they want to like expand on that? Correct? If they want to make it for a whole entire store, a whole entire state, or the whole entire country, right? How do they keep the recipe still tasting like it did when it was just 2 cups of sugar and 3 cups of flour, but do it in massive amounts? Well, they have to find equivalent ratios. They have to keep things proportionate, which is what I'm going to teach you how to do today. So how do we do that? Well, we take the two numbers that we are comparing and we divide them by the same amount. So with our cookie recipe, it was what? 2 cups of sugar to 3 cups of flour. If they wanted to double that, well, then they're going to times it by 2 and they're going to get 4 cups and 6 cups. If they want to like quadruple or even like 10 times it, then they could times that by 10 and get 20 cups of sugar and 30 cups of flour. And it would still taste the same as the cookies that were just 2 cups sugar, 3 cups flour, because they kept it proportionate. They times the two numbers by the same amount. Okay, so let's practice that. Let's figure out two equivalent ratios for 6 to 8. Well, like I said, we can times by the same amount. If you want to double it, times it by 2. If you want to triple it, times it by 3, right? If we double it, that would give us a ratio of 12 to 16. And that means that they are equivalent to each other. Okay, but it's not just timesing. We could also divide or kind of like simplify. We could also simplify the ratio to be 3 to 4. So what we have here is we actually have, oh, whoa, what just happened? Hold on. What in the world? Dun, 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 dun. Please hold. I have no idea where this went. Maybe at the end of that. Oh, whew, okay, cool, we're good. All right, what I was saying before I interrupted myself is that this ratio, 12 to 16, is the exact same as 16. Not exact same, like we can't say they're exact same, right? Because one has a 12 and one has a 6, but we can say they are equivalent, meaning this equal right here sounds equal, right? So they don't look the same, but they are equivalent. All three of those ratios are equivalent. They have the same value, the same proportions. All right, here's another example of when you'll want to use this. Jessa made fruit punch by mixing 2 pints of orange juice with 5 pints of pineapple juice. Like, she worked really hard to figure out the perfect ratio. She didn't want it too sour, but she wanted to have a little bit of kick, right? So she figured out that if you do 2 pints of orange juice and 5 pints of pineapple juice and mix them together, it's like beautiful. Okay, I'm not usually a punch person, but this is delicious. Okay, so delicious that she needs to make more, right? So if she wanted to make a bigger batch, how could she do that? Well, like we talked about, she could double the recipe, couldn't she? She could take the 2 and the 5, double both of them, and you would need 4 pints of orange juice and 10 pints of pineapple juice. And it would taste exactly the same. It wouldn't be too orangey. It wouldn't be extra pineapple-y. It would be the same as doing the 2 to 5 ratio. Okay, so we can double or triple or quadruple, it looks like. One thing that's really helpful when you do these equivalent ratios is look at a multiplication chart, because your multiplication chart often already has those multiples that you're looking for, right? Here's my row of 2, here's my row of 5. So there's that 2 to 5 ratio that she started with. If we double it, it would be 4 to 10, like we just figured out, right? If we wanted to triple it, times them both by 3, then we'd have 6 to 15. If we wanted to quadruple the amount times everything by 4, well, then we need 8 pints of orange juice and 20 pints of pineapple juice. That way they will stay equivalent and it will stay beautiful. A beautiful mixture of orange and pineapple. Okay, so your multiplication chart is a great way to look for equivalent ratios. If you see like 3 to 4 and 15 to 20, you know that they are equivalent. If you see like 2 to 10 and a 5 to 25, you can tell that they are equivalent because they're in the exact same location on the multiplication chart. 6 to 8 is equivalent with 12 to 16. So using your multiplication chart will help you find equivalent ratios. But there's also a few other ways that you can find equivalent ratios. We can reduce both of them to its simplest form and cross multiply, which we are going to do now. So the first example I like to do if I'm asked, hey, are these two equivalent, is reduce both of the ratios to its simplest form. And if down to its simplest form we have equivalent, we have the exact same ratios, then we know that they are equivalent. Okay, so let's do it with this first set of ratios right here. 24 to 4. If you need a reminder of how to find a common factor to divide by, you can GCF, birthday cake it up, and that will help you find the greatest common factor. So if I divide both of these by 4, I will get 6 to 1. So 6 to 1 is the same ratio as 24 to 4. By the way, do you remember that this is a unit rate because it has 1? Remember that. And then let's go on to the 30 to 5. What do 30 and 5, what common factor do they share? 5, right? So if I divide them both by 5, I will also get 6 to 1. So yes, these two are equivalent. 24 to 4 and 30 to 5, okay? Now if we did it to this next number, 1 to 6 is already in simplest form, correct? We can't simplify that at all. But what about 5 to 10? Well, I can divide both of those by 5 and get 1 to 2. If I look, 1 to 2 and 1 to 6 are not the same thing, are they? So these two ratios are not equivalent. So that's the first way to check. If you're given two ratios, simplify them to its simplest form, see if they're equivalent. Another way, though, that's kind of fun is to cross multiply. If you get the same number after cross multiplying, the ratios are equivalent. Here's what I mean by cross multiplying. 3 times 8 is 24. 12 times 2 is also 24. So those are equivalent to each other. They are proportionate. They're the same amount. If we were to do that down here, 10 by 6 is 60, 8 by 10 is 80. Yeah, those are not equivalent. are they? So there's another way that you could figure out if two ratios are equivalent. What if you have a problem like this though? A cookie recipe calls for 4 cups of sugar and 3 cups of sugar. 4 cups of flour, sorry, and 3 cups of sugar. Will a recipe calling for 2 cups of flour and 1.5 cups of sugar taste the same? This one, let's see, we can't really get them in simplest form. Well, it looks like both of them already are in simplest form, right? But this one's kind of funky because it's a decimal. So is it in simplest form? Not really. So that doesn't really work. What about cross multiplying? 3 times 2 is 6. But what's 1.5 times 4? You guys know how to multiply decimals. 1.5 times 4 is, and then decimal it out. Oh, it's also 6. So boom, we know that they're the same by cross multiplying. But did you notice that, well, here's another way, that multiplication chart. If we look on row 2 and just times it by 2, we get 4, don't we? What if we did it this way? What's 1.5 times 2? 1.5 and 1.5 is 3, isn't it? So yes, they will taste the same. Okay, here's another one. If you promise not to say anything, this may or may not be a question like what you'll see on the test. So let's see if we can figure it out. What I want to put all of these in one of these columns, either 1/3, 5/10, or 3/5. Where would they go? For example, 3/6. 3/6 is not the same as any of these, but it is equivalent to one of them. One of the things we can do is we can simplify it. 3 to 6 is the same as 1 to 2, right? So I know it's not going to go to 1 to 3. Okay, but it also, neither of those are 1 to 2, right? But if we simplify 5 to 10, it's 1/2, right? So 3 to 6 is equivalent to 5 to 10. Okay, so you can go through these if you'd like a little sneak peek into your test and see if you can figure out where each of these will go. What we're going to do though is we're going to do another test prep question. Of the 21 people polled about the election for mayor, 12 said they plan to vote for the current mayor. What ratio is equivalent to 12 to 21? Well, it looks like a lot of these are a lot smaller. So I'm wondering if I could divide to get an equivalent ratio. What do 12 and 21 have in common? 3, huh? If I divide them both by 3, I get 4, 2, 7. Found it. And the last question, which might look familiar. Jeff ran 3 miles in 15 minutes. Jushan ran 5 miles in 25 minutes. Did Jeff and Jushan run the same number of miles per minute? So they're asking, hey, are these the same? Are they equivalent? Well, what do you think? There's a few ways we could figure it out, right? We could cross multiply. We could also simplify. Let's do it both ways and see which way you like best, which way works best for you. So if I simplify Jeff, I will get 1 mile every 5 minutes. If I simplify Jushan, I get 1 mile every 5 minutes as well. Boom! Definitely running the same number of miles per minute. Okay? If you want, you could do the cross multiplying. 15 times 5 is 75. 25 times 3 is 75. Either way you do it, you're going to see that they are both equivalent. So yes, they do run the same number of miles per minute. All right, guys, that is it. Enjoy figuring out if two ratios are equivalent, if they are proportionate or not. Catch you next lesson.